Hi guys, welcome back. One of the most common things that you will do in CSS is work with text. The original CSS1 specification, written in 1996, contains the following sentence. Setting font properties will be among the most common uses of style sheets, and they were right. Setting fonts, styling, sizing, and positioning text is half the job in CSS. So let's learn how to do it comprehensively. In this video, we're going to learn all about generic and web-safe fonts, setting a font family, adjusting font size, setting font weight and style, so your bolds and your italics, text alignment, controlling text casing with the text transform property, how to add underlines and overlines to text shadows, setting line height and controlling letter and word spacing. So that's a lot to pack in, so let's get cracking. The CSS properties we use to style text fall into one of two categories. These are font styles and text layout styles. The font style category concerns properties that affect fonts, and these include the font family that is applied, the font size and weight, and so on. Text layout styles affect the layout features of the text, including how text aligns within the content box, the space between letters, and the height of each line of text. We'll learn how to do all of these things, but first we'll start by talking about generic and web-safe fonts. To set a font for your web page, you use the font family property. The value is the font family that you are selecting. A font usually has many variations of standard text, bold text, italic text, etc. For example, this is Times, and this is a combination of many variants, including Times Regular, Times Bold, Times Italic, and Times Bold Italic. Each of these variants of Times is what we call a font face. In other words, Times is actually a font family, not just a single font, even though most of us think about fonts as being single entities, hence the font family property. Browsers can only display text in the font that we choose if it is available on the user's machine. Some font families are built into Windows machines and some are built in on Mac. Of course, it would be too simple for us to expect them to be universal, but some font families are available cross-platform. This page is called CSS Font Stack and illustrates what I was saying. It gives us a list of web-safe fonts and a percentage of machines that have them installed. If you know anything about typography, you will recognize many of these. We see fonts like Arial and Times New Roman have almost 100% availability on both Windows and Mac. Others like Geneva and Lucida Grand are only available to Mac users by default, and fonts like Sego UI and Perpetua are by default unavailable on Mac. So we have to keep this in mind. To ensure a consistent experience cross-platform, we can do one of two things. We either have to pick from one of a pretty small subset of fonts that are compatible with all machines, Arial or Times New Roman for example, or we can include our own custom fonts along with a web page, and this will be the topic of the next video. We will learn to use a great resource called Google Fonts, which gives us many more font families, weights and styles, so thankfully we do not all have to use Arial or Times New Roman and have pretty identical looking websites. But for now, these are some of the web-safe fonts, so we can set a font family of Arial. Some people are still running really old computers with older browsers that they haven't updated, and these would be in the 0.16% of Windows users or the 1.26% of Mac users that are not going to be able to access Arial. So what should we do in these circumstances? Well, we should set up a font stack, which is a comma separated list of fonts added as values to the font family property. We list them hierarchically in order of preference, so the first font we list is the one that we want, our first choice, Arial in our case here. If the user cannot access this font, then the browser will try to display your text in the second font that you list, then the third, then the fourth, and so on. It will move right along the list until there is a usable font. So we'll add Geneva and lastly Verdana. So what we have here is a font stack, but an incomplete one. We need to add one more font, and this is the final fallback. And this is something that has to be the safest choice, something that is guaranteed to load in all circumstances. And this is what we call a generic font. CSS defines 5 generic font types, and these are serif, sans serif, cursive, fantasy, and monospace. Serif fonts have flourishes at the end of strokes, and these are the embellishments that you see here. Sans serif fonts are without these. Cursive fonts have flowing connected strokes that emulate handwriting. Fantasy fonts are decorative, and monospace fonts display every character in the same width. These generic fonts represent the very worst case scenario where the browser will provide a font of that type if none of your other choices in the font stack can be used. The exact font used for each generic font type can vary between browsers. All of the fonts we've seen so far are of the sans serif type, so at the end of my stack I'll add the generic sans serif font. So let's test our fallbacks. If I misspell Arial, the browser doesn't know what we're looking for here and reverts to choice 2 in the stack. We see in DevTools that Geneva is now the font being used, and let's make Geneva unloadable now, and we see that Verdana is the font rendered. If we mess up the spelling for that too, the browser will default to the generic sans serif font. We see here that the browser is choosing Helvetica as its generic sans serif font family. So let's slowly correct the issues preventing the first 4 fonts from loading. Each time we add an accessible font to the front of the stack, the browser says, yep, I can work with that, and we see that our font updates. So hopefully that illustrates how the font stack is working. We had a hierarchical list of different fonts from left to right. If one cannot be rendered for whatever reason, then the browser moves on to the next, all the way down to the generic font that is chosen by the browser. At the moment, this would be applied to only P elements, so I'll change this selector to a body selector. Then it will be inherited by all elements we have, including the paragraph, as they are children of the body. Browsers set default font sizes to all text elements. For example, paragraphs are usually 16 pixels, so if we do not explicitly set font size on an element ourselves, we're simply choosing whatever the browser default is. But we can override these defaults with the CSS font size property. It takes a numerical value, larger than 0, specified in a CSS measurement unit. We have pixels, percentages, ems, rems, and viewport units like VW and VH available, and I'm not going to go into these here as I've posted a series of videos covering CSS units already, and they're there on the channel if you need to brush up. To override the font size on this paragraph, I could say a font size of 20 pixels. If I create an H1 heading, the browser automatically renders it with a default font size of something like 32 pixels, and I can override that by saying H1, and we'll give it a font size of 40 pixels, and we see that the font scales up in size slightly. If I add a link and a span inside our paragraph, we see that the text in both is the same font size as the paragraph, which is the parent of both of these elements. If I change the paragraph's font size to 25 pixels, the link and span scale up. And if I modify that to 16 pixels, both the link and the span scale back down. The text of the link and the span are inheriting font size from the parent element. That doesn't mean that we can't give these elements their own font size, and that's what we're doing with the paragraph. Without us specifying font size, the paragraph and its children look up through the document for their font size. Where none is set, it takes it from the body or from the root HTML element. The root HTML element is actually where it's best to set font size. If we set it there, we can use it as a base to set consistent font sizes with rems through the document. So if I set it to 62.5%, which is 62.5% of the default 16 pixels the browser sets, then we're setting font size to 10 pixels. The rem unit takes its size from the font size set on the root HTML element. So throughout our document now, 1 rem is equal to 10 pixels, 2 rems is 20 pixels, and so on. So instead of saying font size is 16 pixels on the P element, we can say it is 1.6 rem. I explain this in much more detail in the Ms and Rems video, so go check that out if you're interested in learning more about rems and how they scale up and scale down nicely across our pages. But we'll move on now to talking about font weight and style. The CSS font weight property allows us to control how bold our text is. We specify values either as keywords or as numeric values. Keywords include normal, which is the standard weight we would be familiar with, and this corresponds to the numerical value of 400. We would also be familiar with seeing fonts in bold, and the bold keyword gives us, you guessed it, a bold font. This is the same weight as a numerical value of 700. So we see already that there's more than one way to achieve exactly the same result, and which you use is a matter of personal preference. Numeric values are always multiples of 100. Generally speaking, the heavier a font weight becomes, the darker and bolder a font appears. 100 being the finest font weight and 900 being the heaviest. Not all fonts have weights that cover the entire range. Most of the default fonts we've seen only have font weight options of 400 and 700. If I try 100, 200 or 300, we see nothing changes with this standard font family. I can do 700, which we know corresponds to bold, but not 800 or 900. So the browser has to determine the font size that it will use if there are fewer than 9 weights in a given font family and one that is not in use has been selected. If the value 500 is unassigned, it is given the same font weight as 400. If 300 is unassigned, it looks down for a variant lighter than 400. If no lighter variant is available, 300 is then assigned the same variant as 400. This same process takes place for the 200 and 100 weights. If 600 is unassigned, it looks for a variant darker than 500. If no darker variant is available, 600 is assigned as whatever 500 has. This method is also used for 800 and 900. If nothing is available for these variants, they usually look down to 700, which corresponds to bold. Let's move on to font style, which allows us to make our text italic. Simple as that. It has 3 possible values, which are normal, which is the default font style. You only ever use it to turn existing italic text off. Then, of course, there's italic, which sets the italicized variant of the font. And if there is no italicized version, selecting italic will produce oblique text. It looks italic, but oblique text is created by taking the standard font and slanting it at a given angle rather than displaying the italic font face variant. You can, of course, also create italic text with the HTML M element, which stands for emphasis. You can create bold text with the strong element. But it's better practice to use CSS to style text. HTML should just be structuring things. Any stylistic changes to text, or anything else for that matter, should be done with CSS. The text transform property is what we use to control the casing of our text. You can write the text in whichever casing you like, then override that using only CSS. We can have all uppercase text, all lowercase text, or alternatively, we can capitalize. Capitalize makes every first letter of every word uppercase. We can also use none to remove the CSS text transform from an element that it currently exists on and revert the casing to whatever is written in the HTML. Next up, we'll talk about how we underline text, and we do that with the CSS text decoration property. We can also add an overline, which is uncommon, and we can also put a line through text so that it appears crossed out. We might use this for a to-do application, where we might check items off of a list by toggling this style on with JavaScript when a list item is clicked. We can also select none to remove any of these lines if they exist on an element. A common use is on links, for example. Some developers prefer to remove the underline and instead make links stand out by making them a different color. We're not limited to single keyword properties. The text decoration property can take multiple space separated values. Text decoration is actually a shorthand property that controls what text decoration line, text decoration color, text decoration style, and text decoration thickness do separately. Text decoration line does what we've seen, but we could change the color of our line with a keyword or a color code in whichever format we like. We can set thickness, and we can suggest the style of the line. So solid is the default, but we could have dashed or wavy instead. So there's an assortment of properties we use in this shorthand text decoration property that gives us a lot of variety with the lines we can draw under, over, or through text. It works very similarly to the CSS border shorthand property. We don't have to have the space separated values in any particular order. They will work wherever you place them within the selector value. As we are decorating with lines, we may as well decorate some text with shadows too, and there are several kinds of shadows in CSS, like box shadows, which you may know, for example, and these would place a shadow around an element's box and not follow the shape of the letters themselves, like the text shadow property. At a minimum, we need to specify horizontal and vertical offsets, and this gives us a shadow that is essentially a mirror image of the text. So we should specify a color lighter than the color we're using on the text. So the first number controls the x-axis. Positive numbers move the shadow to the right, and to move to the left we decrease the number that we have. 0 aligns the shadow exactly with the text on its axis. To move to the left of this alignment, use negative values. The second number controls the y-axis. Again, 0 places it perfectly aligned on the axis. Positive numbers move the shadow below your text, and negative numbers move the shadow up. We can also control the blur radius of the shadow. 0 is the default value, and numbers below this do not produce a shadow. So you cannot use negative numbers to produce a shadow. Positive numbers are what we use to increase the blur. So to have the shadow scale consistently with different text sizes, I recommend setting it in ems. And this is true for any element actually that should scale in a fixed shape, like margins, paddings, and the border radius on buttons that might appear in slightly different sizes across a page. With ems, the shadow is the same positionally in relation to the text when the size of the text scales up or down, as it is setting itself relative to the font size. If you feel so inclined, you can add multiple shadows and create some wacky effects. There's this really cool tool that allows you to create and mess around with your own fancy shadows. You can create neon glows and whatever else you're into. The last few properties we'll look at are related to alignment and spacing, starting with the text alignment property, which gives us control over the horizontal alignment of a block of text. Text aligns to the left by default, but we can center it, align it to the right, or justify it. Justified text is aligned to the left, but it is spaced so both sides of the text block have a clean edge. All fairly straightforward, but we need to keep in mind that we're talking about the alignment of block level elements. Block level elements stretch the full width of their container, so they have space to align in different ways. Inline elements, like spans for example, only take up the space that their content requires and no more than that. So setting text align to an inline element has no effect. Just spacing left for this video, and we've got 3 properties: line height, letter spacing, and word spacing. Line height sets the height of each line of text. And if I highlight the text as I change the height of the line, you see that the text sits in the middle of the line and gets an equal amount of space above and below the text. You might also have noticed that when specifying line height, I did not use a CSS unit. Line height can take CSS units. I could say 2 rem or 35 pixels for example, but a unitless value just specifies a multiple of the font size, making it scalable. The recommended line height is usually around 1.5 to 2, and 2 gives you a double spaced line. Letter and word spacing do exactly what you think they do. We can add a space that differs from the default option. We could add 100 pixels between each word, for example, which replaces the ordinary spacing that the browser provides. And letter spacing is exactly the same idea, but it adds a space between each individual letter. These are not really common properties to use, but useful to know. You may find a use for them if you want to obtain a specific look or to improve the legibility of a particular font. Okay, so that's most of what you need to be able to do to work competently with text and fonts. The rest we're going to pick up in the next video. And so far, we've seen how we set a font family, we've seen generic and web-safe fonts, and how we create font stacks with fallback options. We've learned to adjust font size, weight, and style, and now know how to align and space our text, add lines and shadows, and also specify the casing. So we've packed quite a lot in, and there's a little bit more work to do with fonts, and in the next video we're going to learn how to use custom fonts and how to make use of a really great tool called Google Fonts and access all these extra font weights that we know exist. So thanks so much for watching. I hope you found the video useful. I really do appreciate your time, and I'll see you in the next one.